Alright, time for another exciting episode of Unit Reviews. This is your Unit 8 review. I'll make this as exciting as possible, and when I say that, I'm lying because I'm just going to be the same as it's always been. You'll get over it, I promise. So here goes. What geometric shapes can be used to model the picture? You're going to see a question like this on your EOC. Just look at the picture. Pick out which shapes you see in here or which shapes over here you would use to create that. A cone, I don't see any cones anywhere, so that's not one. A pyramid, again, nothing's coming to a point, no pyramids. A hexagonal prism, hexagon, you gotta know your shapes. Hexagon, 6 sides, this is definitely not 6 sides. That's not one. A cylinder, yes? These are cylinders here. There's 4 of them. A sphere? Nope. A square prism? Yes, I can't guarantee that's a square, but it looks like a square, so there you go. These 2 answers are your answer choices. It's really a common sense question, as long as you know your shapes. Hopefully you know your shapes. Alright, 2. Points x, y, and z form a triangle on the coordinate plane. If the area of the triangle is 9 square units, then which of the following are possible coordinates for z? Before I even turn this board over and start graphing these, it says the area of the triangle is 9 square units. The area of a triangle is base times perpendicular height divided by 2. They didn't give me the side. I can find the side. How big one side is. X is at 7, negative 3. So here's 7, negative 3. This is x. Y is at 7, positive 3. That's not 3. Sorry, guys. Spring break. Just 1, 2, 3. Forgot how to count. 1, 2, 3. There's y. I'm looking for z. But I do know this. And from positive 3 to negative 3, I do know that this is 6. Which is telling me one of my sides is 6. The area is 9. So 9 equals 6 times h divided by 2. Simplify. 6 divided by 2. 9 equals 3h. Divide by 3 on both sides to get h by itself. And h is going to equal 3. Which means my point z has to be perpendicular to this side. Because to find the area of a triangle, it's base times perpendicular height. And 3 units away. So 1, 2, 3. It has to be somewhere on that line. 1, 2, 3. Or on that line. Now all I do is plot my answer choices. See which one works. Actually, I don't even have to do that. This is at 1, 2, 3, 4. And this is at 10. Therefore, I'm looking at, this is my x axis, looking for an x coordinate of 4 or 10. There it is. Done. Don't even have to graph it. If I did graph it, that's at 10, negative 3, which would be here, which would give me this triangle. This length is 6. It's perpendicular. That side is 3. 6 times 3 is 18. Half of 18 is 9. There you go. Alright, the height of both prisms are the same. Using Cavalieri's principle, determine which statements, look at that, statements, more than one, must be true. Cavalieri's principle says if they have the same height and the same cross-sectional area, which means if I take a cross-section anywhere, if these are the same areas, then they have the same volume. So if the area of the base A is equal to the area of base B, so if they're equal, the volumes are equal, then B has a greater volume. No. If they're equal, the volumes are equal. The area of base A is equal to the area of base B, then A has a greater, nope, they're equal. If the area of A is equal to the area of base B, then the volume is A is equal. Yes. If the area of the base A, so if A is less than B, if the area of this base is smaller than the area of that base, then the volume of this should be smaller than the volume of that. Area of base B, then the volume of A is less than the volume of B. Yes. If the area of base A is less than the area of base B, then the volume of A is less than. So that was a typo. I typed the same thing twice, but regardless, all three of those are correct. If Cavalieri's principle, they have equal heights, which they tell you right there, and the bases are equal, then the volumes are equal. Well, in the same aspect, if they have the same height and the area of one shape is smaller than the area of the other shape, then the shape that has the smaller area naturally is going to have the smaller volume. Alright. What would allow you to determine if A, B, C, D, E, 1, 2, 3, 4, 5, so that's a pentagon, is a regular pentagon? Coordinates on the vertex? Always. Anytime you see that, always. Length of each side? Yes. Because regular means all sides are equal. The measure of each angle? Yes. Because this is 5 sides, which is an odd number. Any odd number shape, if the sides are equal, the angles have to be equal. Which is why in a triangle, an equilateral triangle has equal angles. An equal angular triangle has equal lateral sides. So if this is odd, then all you need is one of these and it tells you if it's regular or not. So all three of these are your answer choice. Because in the same way, if the angles are equal, then the sides have to be equal. Alright. A square pyramid is cut by a plane. The plane intersects the pyramid at the midpoints of two of the base edges, and one lateral edge that share the same vertex. What type of polygon is formed by the cross-sectional face? Blah, blah, blah. You're taking a three-dimensional shape and turning it two-dimensional by cutting it. So let's see if I can draw this. A square pyramid. I don't know how I want to draw this. Actually, that one's solid. That one's dotted. That one's solid. That one's dotted. Okay, if you can see this, actually this is solid. So, this is dotted. Dotted lines are behind the shape. There's your square pyramid. It says a square pyramid is cut by a plane. So I'm taking a three-dimensional shape and I'm just slicing it. The plane intersects the pyramid at the midpoints of two base edges. This is the base. So the midpoint, two midpoints, and they called it a square. So it's a square pyramid. And one lateral edge. Midpoint of the lateral edge. That share the same vertex. So they all share this vertex. So the midpoint here. So I'm trying to figure out what shape was just created. If I cut this off, there you go. What shape is that? And you have to be extremely specific. A triangle won't cut it. Of course it's a triangle. What kind of triangle? Can you guarantee to me that it's any triangle? Well, if this is the midpoint and this is a square, then those are both midpoints. Then the distance here has to equal the distance there. So I can call this an isosceles triangle. I do not know if this side equals those two sides. Can't guarantee that. I can guarantee those two sides are at least equal. Therefore, it's an isosceles triangle. Be careful on this question on your test, guys. Isosceles triangle is going to mean an answer choice. It doesn't necessarily mean that the isosceles triangle is your answer choice, My questions are similar to the test, not exactly like it. For those of you that still do not cheat, you will realize that for those of you that do cheat, I don't even know why you're wasting your time watching this video. You already know the answers, which is very sad. Alright, next one. What is the ratio of the area of the triangle ABC to triangle XYZ? Ratio of areas. Ratio, all this means is fraction. Anytime you see ratio, this means fraction. Whatever they list first goes on top. To triangle XYZ, they listed this second, goes on bottom. What goes on the top and the bottom? The area. That's what they want. So ABC is 4, 5, 4, 1, 7, 1. Look, they even gave a right triangle. How convenient. It's very convenient since I made this. This side is 3. This side's 4. 3 times 4 is... Well, let me start from the beginning. The area of a triangle. Base times perpendicular height divided by 2. So this would be 4 times 3 divided by 2, which is 12 divided by 2, 6. The area of that triangle is 6. That's my first triangle, so it's going to go in the numerator. The second triangle, XYZ, is at 2, negative 4. Here's X. 8, negative 4. Y, and 8, negative 8, Z. Here is the second right triangle. This side is going to go from 2 to 8, so it's 6. And this goes from 4 to 8, so it's 4. And again, the area of a triangle is base times perpendicular height divided by 2, which is 6 times 4 divided by 2, which is 24 divided by 2, or 12. That's the second triangle they listed, so it goes in the bottom. If you leave it like that, you are wrong, because you need to simplify. This is 1/2. The area of the two triangles, the ratio of the areas of the two triangles is 1/2, which is telling you that this triangle is half of that triangle. That is all. If you really study, this is a very easy test not to cheat on, not to disappoint all your teachers. Alright, what is the perimeter of the polygon with vertices at? This is one of those awesome perimeter. This word just means add the sides. A is at negative 2, 3. Negative 2, positive 3. There's A. B is at 2, 3. 2, 3. B. C is at 5, negative 1. C. 1, negative 4. D. 1, negative 6. Remove my D. E. Negative 2, negative 2. 1, 2, 1, 2. There you go. So what is that? F. Alright. Connect the dots. If you know your alphabet, you should be good at this. A, B, C, D, E, F, A. There you go. Find the perimeter. Add up all the sides. 1, 2, 3, 4. That's 4. That's slanted. That's slanted. That's easy. That's 2. That's slanted. 1, 2, 3, 4, 5. That's 5. Alright. The easy ones are done. Now I gotta do the hard ones. How am I gonna do the hard ones? You turn them into... Well, actually, not all of you that watch this video have me as a teacher. So yes, you can use the distance formula. The square root of x2 minus x1 squared plus y2 minus y1 squared, and find the distance. You have to find this point, x1, y1, x2, y2, blah, blah, blah. I don't do it that way. Way too long, way too annoying. Nope. You use this Pythagorean theorem. Find your right triangle. There it is. So this is 3, that's 4, and if you're in my classroom, you automatically know this one is 5, because that's a 3, 4, 5 Pythagorean triple. If you don't believe me, plug it in. 3 squared plus 4 squared equals c squared. 9 plus 16 equals c squared. 25 equals c squared. Therefore, c equals the square root of 25, which is 5. Exactly what I said, because I'm never wrong. This right triangle, again, is 3, 4, amazing, it's 5. Last one, 3, 4, what are the odds? Considering I made this review, the odds are very high. Now, we have all the sides. I'm going to erase my triangles because this is just too messy. We have all the sides. Put my 2 back. Let's add them up. You have 5, 10, 15, 20. 4 and 2 make 6, so your answer is an amazing 26. Which one was that? This one? Alright, a square pyramid has a base edge of 14 and a height of 24. The pyramid is intersected by a plane exactly halfway between the top and bottom. A smaller pyramid is created by the intersection of the plane and the pyramid. What is the volume of the smaller pyramid? Awesome. So, I'm not going to draw the pyramid. It's a square pyramid. So there's my pyramid. Then I have a plane cutting it in half. They want to know what's the volume of the smaller pyramid. On the large pyramid, they told me that, I'll put it off to the side, the height was 24 and the base edge is 14. So the volume, area of the base, perpendicular height, divided by 3, because this is a pyramid. Pyramids and cones divide by 3. A couple ways I can do this. First way is just to find the volume of the larger one. The volume of the larger one is going to be the area of the base, which is just 14 times 14 times 24 divided by 3. And I forgot a calculator in here. So I'm going to have to pull up the calculator on the computer. And it tells me 14 times 14, 196, times 24, divided by 3 is equal to 1568. So the volume of the large one, I'll put an L, is 1,568. Now, my scale factor was 1/2. They told me that the two pyramids were intersected halfway. So it's 1/2. You don't just take half of this. 1/2 is the scale factor. Scale factor. And then you have perimeter, area, volume. If your scale factor is x, your perimeter is x. The ratio of perimeters, the ratio of areas is x squared. The ratio of volumes is x cubed. So I actually have to cube the 1/2 because my scale factor, they said, is half because it was cut in half. So 1/2, which means my volume is 1 cubed over 2 cubed, which is going to be 1 over 8. 2 times 2 is 4, times 2 is 8. So I'm going to take that number and I'm going to divide it by 8. 196. So the volume, put this over here, of the small shape is 196 units cubed. I'm going to show you another way. This other way will probably be easier, but whatever, I like that way. So if this pyramid was cut halfway up, if it's halfway up, that means this is half, which is 7, and that means the new height is half, which is 12. Then the volume is area of the base times the height divided by 3, which is going to be 7 times 7 times 12 divided by 3. This one is a little easier. 49 times 12 divided by 3. 49 times 12 divided by 3 equals, you're going to be amazed, 196. Either way, you're going to get the right answer. Use the ratio of volumes, or just cut it in half. Find the volume of your new shape. Okay. A regular pyramid, a triangular pyramid, and a sphere have the same volume. Ooh. The base of the pyramid is a right triangle with legs of 4 pi and 6 pi. The height of the pyramid is 9 pi squared. What is the radius of the sphere? Here goes. You have I will try to draw these. Right triangular pyramid and not good at drawing circles, sphere. Okay. The legs, they said the legs were 4 pi, 6 pi, and the height, put it off to the side, was 9 pi squared. Here goes. They have equal volumes. I need to find the radius of the sphere. The radius of the sphere. They have equal volumes. The volume of a triangular pyramid is area of the base, perpendicular height divided by 3. The volume of a sphere, 4/3 pi r cubed. Most of you are going to tune this one out because this one actually involves math. Imagine that. On a math test, they're going to ask you to do math. Says the volumes are equal. Set them equal to each other, guys. Base times height divided by 3 equals 4/3 pi r cubed. It says the volumes are equal. Make them equal. Now, this is the triangular pyramid. I can find out stuff about this guy. The volume is actually area of the base. So it's area of a triangle, 4 pi times 6 pi divided by 2. So it's going to be 4 pi times 6 pi divided by 2 is the area of the triangle. I can actually multiply this out. This would be 24 pi squared divided by 2, which is just 12 pi squared, times the height. The height was 9 pi squared. So times 9 pi squared. So this becomes 108 pi to the 4th. Good. 12 times 9 is 108. Pi squared times pi squared is pi to the 4th. When you multiply, you add exponents, which is why when I multiplied, the exponent's 1, the exponent's 1, which is why it became squared. Now I have 2 squareds and I'm multiplying, add the exponent, 2 plus 2 is 4. So instead of writing this, I now know the volume of the triangular pyramid is 108 times pi to the 4th. Do not give up on this question. Stop being lazy. Stop not trying things. You are guaranteed to fail on 100% of everything you don't try. Now I gotta get r by itself. Before I get r by itself, let's multiply by the reciprocal here. So I'm going to multiply by 3/4 so that these cancel. These, they don't cancel, they simplify. Multiply by 3/4. So I'm going to take 108, 108, multiply it by 3, and then divide it by 4, because that's all a fraction is. You multiply a numerator, divide the denominator, you're left with 81 pi to the 4th equals pi r cubed. Now let's get rid of the pi. Divide by pi. Those simplify. Divide by pi. These don't simplify. This simplifies with one of them, so it becomes a 3. So now you're left with 81 pi cubed equals your radius cubed. Let me put this in the calculator. I got the wrong number, and I don't know why. Divided by 4. Bear with me for a minute. That's why. I didn't divide it by 3, guys. I didn't divide it by 3. I didn't divide it by 3. I didn't divide it by 3. Where'd this go? Do you see it? This is the area of the base. That's the same. This is area of the base times the height. Here's your area of the base. Here's your height. I never divided it by 3. So this has to be divided by 3. And 108 divided by 3 is 36. So this becomes 36. I messed up. Surprise, surprise. I'm human. I'm never wrong. I wasn't wrong. I just messed up. Alright, we're going to do the same thing. We're going to multiply by 3/4 so that the same things cancel out. Multiply this by 3/4. This is going to give us a different number, a better number, because 36 times 3 divided by 4 is 27. So this gives me 27 pi to the 4th equals pi r cubed. Divide both sides by pi. Again, that only cancels with 1, so you're left with 27 pi cubed equals r cubed. To get r by itself, you have to take the cubed root of r. So what number, when you multiply it by itself 3 times, gives you 27? The answer to that is 3. Pi cubed, take the cube root of it, is just pi. So r equals 3 pi. That's the radius of the sphere. Watch that question again for those of you who really want a shot at this. This is not a hard question. You just have to remember all the pieces. I forgot to divide by 3. It's a big piece of this volume formula. Find the area of the base, multiply it by the height, then divide by 3. Alright. This one. Frank cut a circle with a circumference C and a radius R into 8 congruent sections. 8 congruent sections, which means each piece up here is equal to itself. Sectors, not sections. Used them to figure out figure shown. Frank noticed that the figure was very close to the shape of a parallelogram. Choose all that apply. the height of the parallelogram is approximately equal to the circle's diameter. Well, if this is just a piece of the pie, it's a sector, that means this went to the radius or to the center of the circle, so that is the radius. The height is equal to almost the radius, not the diameter. The area of the parallelogram is approximately 0.5 c times r. Okay, area of a parallelogram is base times perpendicular height. The radius is approximately the height, so we can change the h to an r. This is the outside edge of the circle. Is this the whole thing? No, because this is also the outside edge of the circle, which means this, the base, is half of the outside edge of the circle, which is 1/2 the circumference. Or, as this is putting it, 1/2 is the same thing as 0.5 circumference times radius. So yes, to B, the length of the parallelogram is approximately equal to the circle's circumference. We just figured out that's a no because it's half. The radius of the circle is approximately equal to the height. Yes. The area of the parallelogram is approximately this. Alright, area. If I can find the area of just this and then multiply it by 8, it gives me the area. Well, what is this? This is a sector. So the area of a circle, pi r squared. To find the area of a sector, remember you're adding that theta divided by 360. This was cut into 8 equal pieces. Therefore, all you need to do is 360 divided by 8. 360 divided by 8 is 45. The radius is approximately equal. No, we're done. We're done. Pi r squared. If I find the area of the sector, multiply it by 8, it'll give me the area of this, which looks astoundingly like that. So there you go. Again, not a hard question. What are we going to estimate? The volume of a stone column if the height of the column is 20 feet and the circumference is 72. Let's go back to the board. Stone column. What is that? It's a cylinder. There you go. So the height is 20. They told you the circumference of the base is 72. Well, the circumference of a circle is 2 pi r. So if the circumference is 72, that means we have 72 equals 2 pi r divided by 2. This is telling you, actually, if you divide by 2 pi, then you'll have your radius, which is going to be a decimal. Actually, 72 divided by 2 is just 36. So I'm going to make this easier. 36 is equal to pi times r. Then you divide by pi. I'm going to leave it like that. So 36 over pi is equal to r. That's the radius. I need to find the area. Area of the circle, pi r squared. Well, I now know what r is. So area equals 36 over pi squared times pi. Well, this becomes 36 squared is 1,296 over pi squared. The squared gets distributed to both times pi. This pi is going to cancel with one of those. So the area is equal to 1,296 divided by pi divided by, this isn't one of those that tell you use 3.14. pi equals, that's the area of the base, times the height, because it says to estimate the volume of the stone, times 20. And I'm wrong again. This time we're wrong on all of it. All of it, 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 all of it. All of it is wrong. Why is all of it wrong? Let's zoom in here. All of it is wrong because this is in feet and that is in inches. Let's change 72 from inches into feet. You are going to get 6 feet. This is 6 feet, which changes everything. It's okay, guys. I'm just making the video longer. I know how much you like that. This is still 20. The circumference is now 6. So 6 equals 2 pi r. So divide by 2 pi equals your radius. So my radius is going to equal 3 over pi. The area of the circle doesn't change. Pi r squared. The area is 3 pi squared times pi, which is 9 over pi squared times pi. That simplifies, and you're left with 9 over pi. Now I'm going to find the volume of this. So it's the area of the base, which is 9 divided by pi, times the height, which is 20, and you get approximately the volume of this cylinder is approximately 57.3. Doesn't tell me where to round. Your test will. I didn't. Next question. Gas tanker. Good old gas tanker. You have a gas tanker. I'm putting my, which is still just a cylinder. Putting it this way. Tank is 53 feet long. Let's make sure I keep everything the same with a radius of 3 feet. It's 75% full. What is the volume in cubic feet of gas in the tank? Use 3.14 for pi. Again, volume, area to base times height. This is a circle. So my capital B is pi r squared, where my radius is 3. So it's pi times 3 squared, which is just 9 pi. The height is 53. So I'm going to take the volume, which is 9 pi, multiply it to 53, that's going to give me the volume of the entire tank. 9 times pi, nope, not pi. Does not say to use pi, it says 9 times 3.14. Pay attention to that. Times 53 is 1,497.78. That's the entire tanker. Doesn't want the entire tanker. It says the tank's 75% full, so I have to multiply this by 0.75. You're multiplying it by your decimal. Don't multiply it by 75. Multiply it by 0.75. 0.75 to give you a final answer of 1,123.34 cubic feet of gas in that tank. Oh, this is taking forever. 40 minutes. You guys are going to love this video. Right. John wants to estimate the volume of an air inside a hot air balloon. Which formula would you use to figure this out? Well, we got to know what a hot air balloon looks like. Hot air balloon is circular. So I'm using the sphere. Easy question. Easy question. Oh, thank God. Last one. Triangle XYZ. I didn't label it. X, Y. Now I labeled it. There you go. Triangle XYZ is revolved 360 degrees about the axis, the x-axis, to generate a three-dimensional figure which best describes the shape of the figure shown. Now you got to imagine that this triangle is going around and spinning and spinning and spinning and spinning and spinning and spinning. So what is it creating? If it spins, it creates a cone, a cylinder from which a pyramid is removed. If you're spinning this way, I don't see you removing the pyramid. A rectangular solid from which a cone is removed. It's not rectangular. It's going in a circle, so it's going to be a circular base. A cylinder from which a cone is removed. No. None of these are right, huh? A rectangular solid from which a pyramid is removed. It's not a rectangle. It's definitely a cylinder. This one and this one are automatically out because you're going in a circle. So it's going to be a cylinder. But if I rotate this around and around and around, that's what the base is going to look like. It's just going to be a cone. So look, answer choice D. Cone. There you go. That's the one. Pick it. That's it. That's the test. Alright, guys. You enjoy this 41-minute review. Study, study, study. And we'll have the test the week you get back from spring break.